Alright, this is the CT-610 Mark II, which I already introduced in a past video. It will be linked above. And as I expected, it was basically a lot of nothing inside. It's a very empty, very empty box, very light. So the circuit is extremely simple in the sense that actually for repairing or not. The only thing, I don't think there will be much work to be done in this. Is also extremely clean because it's completely closed, so it's really protected from the elements here. And I'm just gonna check for its functionality, see if it's actually has the sensitivity is good and whatnot. But overall, I'm gonna get a bit another take here just to showcase its internals. But overall, it's in excellent shape. And the work will not be as intense as in the amplifier, because also the value for my friend is not as big to have a tuner, but let's see what he decides to do with it. So starting with the back panel, just a tiny small transformer, very high quality. The transformer is very high quality, but super small. This is the power transformer, and connected here there's two big protection capacitors. And the fuse is actually down here. I'm not sure if, yeah, it's on the angle. So the fuse is actually down here. And these are just the connections. Oh, there's like a stand here, a support here for this is for the light. I'm gonna show it in another angle. And these are the back connections for the antenna and for the audio here. Okay, this is the rear view of the front panel. And the first thing that actually calls for attention is the big weight here. This looks like a bell, but in fact is actually a massive weight. So that gives you a very soft movement on the dial, which it's actually pulled. This is the button of the dial, which is mechanically attached to the rest of the systems via the system of strings here. And this string here is in excellent shape. There's absolutely nothing to be done here. And of course, when you move this, it also moves the dial itself. Mechanically moves the dial back and forth on the front plate, and also moves the big wheel here, which is all tension. There's a small spring here that actually tensions this cord, creates a tension to this cord. So everything is actually set in place. And this part here is actually when the mechanical system connects to the electrical system, because this is the variable capacitor. So this obviously translates from a mechanical movement to a change in the capacitance in here. So you can actually get the actual tuning of the stations across the band. And there's multiple sections, so one section for AM and one section for FM. And apart from this, the rest of it are just like some lights in here. There's just a small PCB with lights in here. There's the two intensity. One is the typical intensity and the other is tuning VU meters that are on the front that actually help indicate when you're tuning stations. And this is the switch, the wave band switch, which is typically a somewhat complex switch. So this is kind of irreplaceable if it goes bad. This is the output level. This is just a potentiometer with the output level, and this is of course the on-off switch. And of course the board, I will actually get closer in there. Oh, one additional detail. This is the entire support actually to keep a light, an LED on the dial itself. So you can actually move without breaking cables and tangling on the other mechanical systems. All right, so that's the board. Okay, so basically the signal input here comes on this side. This is the differential antenna for the FM, and this is the single-ended antenna for AM. But they both get inside the front end here. The front end here is actually completely shielded. It has two adjustments here because this is actually one of the adjustments for the intermediate frequency for FM, and one is for AM. Whatever it is, you just need to check on the manual. And once it gets here, of course, the front end part of it including the intermediate frequency oscillator, the local oscillator as we call, it's completely connected to the variable capacitor. So this entire set here is basically what it actually does the tuning of the station that you want to listen. So of course, and then the signal probably goes through. Oh yeah, so it goes, and then the signal starts taking different paths in here. This is a local AM path, so it has the RF amplifier, the tuned amplifiers through all these small coils in here. So these are the tuned amplifiers to amplify the RF signal directly. And this is the path with these amplifiers in here. Hopefully it can be seen. There's a tiny little one here, and there's two other ones. This is the operational amplifiers. This part here is the FM radio. So it has some mixers in here, and not only that, not mixer, it has some different filtering here, which especially with the ceramic filters. I don't know if it can be seen here. There's two green ones here, actually a third one here to filter out the intermediate frequency of FM. And these filters in here, they actually they actually are switched by the main switch here, by the main band switch here, because you can detect a filtering for stations at distant stations. So you can actually decrease selectivity, so you actually cut off some of the filters, but you increase the distance setting is increases sensitivity at the expense of selectivity, meaning it's easier to get two stations mangled together because you're not filtering as much, but because every filter that you apply in the chain actually decreases the sensitivity of the receiver. Or if you have only local stations, this is very common. If you have local stations, you increase filtering because then you can actually increase selectivity, so you can actually discriminate between the different stations easier. And overall, so this is the section for FM, which has all these details. AM is pretty straightforward. Basically selects AM band and that's it. And then of course everything moves on to the audio amplifier. So the audio amplifier should be here. Oh yeah, it's hidden beneath these wires in here. It's a 14-pin DIP IC. So this is just the plain audio amplifier in here that shoots straight to the output control, and it goes through this wire all the way to the back panel. And also these bigger capacitors in here are just the power supply, and of course it's just sprinkled with a lot of tiny little capacitors in here, electrolytic capacitors in here. But overall I can tell that from the state of the power amplifier and how well these capacitors still were back in the amplifier, I can almost guarantee that all these capacitors are still in excellent shape, because they're the same brand, the same make, it seems to be about the same age. But the difference is that this guy here does not operate under extreme thermal stress like the power amplifier. The power amplifier operates a lot hotter than this one. So I'll be very surprised if there is a rotten capacitor somewhere in here that could be caused by temperature and whatnot. So overall, that's the basic circuit. Of course, there's this on-off switch as here, and as I mentioned, and maybe the fuse here. I'm not sure if it can be seen here. Yeah, that's the fuse here. So overall, that's pretty much it. And of course, there's a few circuits in here that actually detect. They're actually and discriminate the signals to lit up the lights for the tuning and for the VU meters and whatnot. So there's a few circuits around here. So that's pretty much it. The overview of the circuit of the AM/FM radio. Pretty straightforward, but it's not that simple because it has a lot of switches and selections. That's what it causes it to be a little bit more complex than your regular few transistor radio that you could carry in your pocket.